Assalamualaikum and hi. I wish a very good day to our lecturer, Professor Dr. Wan Azlina. Today, we would like to explain about our heat exchanger design under the subject heat and mass transfer processes. So, we are from group 14, which is consisted of me, myself, Muhammad Ikhwan bin Muhammad Shafi'i, and another two students, which are Ang Yi Feng and also Rishi Varma anak lelaki Chandra Segar. Okay, let's take a look at the problem statement for our design. In the urea production industry, unusable and excessive carbon dioxide is frequently generated. Heat exchanger is used between carbon dioxide stripper and CO2 storage tank to lower the temperature of CO2 until freezing point and stored in the storage tank. The inlet stream of heat exchanger receives CO2 at 10 degrees Celsius and about 3,750 mm Hg of pressure, with a mass flow rate of 243,000 kilograms per hour. At the outlet stream, cooled CO2 is obtained at negative 15 degrees Celsius. The coolant, on the other hand, has a mass flow rate of 85 kilograms per hour. Now, let's proceed with the heat exchanger description, in which I will go through one by one. So the type of heat exchanger that we have chosen is shell and tube heat exchanger. So the purpose is to cool the CO2 by reducing the temperature from 10 degrees Celsius to negative 15 degrees Celsius. The description of our heat exchanger is the diameter of the steel tube is 0.009144 meter. The length of heat exchanger is 5 meters. The flow of fluids in the shell and tube will be turbulent flow. So for the refrigerant that is used in the heat exchanger is called R410A. So R410A refrigerant is used as cooler in the shell side for this for this operation, while CO2 is in the tube side. R410A has many advantages over other heat transfer fluids such as more energy efficient, since it absorbs and discharges heat better than other fluids. It is also environmentally friendly and it is less expensive.
Okay, thanks Ivan for explaining. So right now we'll be going to the calculation part in our group heat exchange design process. So in this part, we use the NTU method to calculate the length of the the length of the heat exchanger. So the NTU formula for the one shell and tube heat exchanger is negative 1 over 1 plus c square root ln 2 over effectiveness minus 1 minus c minus 1 plus c square root over 2 over effectiveness minus 1 minus c plus 1 plus c square root. So by using this NTU method formula, we can go and we can find uh, the heat exchanger length if we assume the U and also the diameter. So the U for the U, right, we pick it from the online articles, and it is 345. And for the diameter of the heat exchanger, we assume it to be 3 meter. So next, so this is a prototype that we have produced. Our group heat exchanger design prototype will be a little bit different, since for the commercial heat exchanger, right, there will be one side that design will be the shell is situated in between inside the dimension of the pipe. But however, since our group face a little bit problem with the baffle and also the tubes, since the baffle is 2 meter while the tube is 3.6 meter, so which means that there isn't much difference. So we on our solution to make this is by situating it in by making it to be in the center. So which means that the pipes section will be in between the both ends of the shield. So it'll be a little bit different with a commercial heat exchanger. So if you see for if you guys see from the prototype preview, so we can see that for the upper side there will be the two opening, which is one is for the 410A to enter the shield, and the other one is for the CO2 to exit the pipe. And for the downward is it's the same thing. So CO2 enter from downwards and exit from the upwards, while R410A enter from upwards, exit from downwards. So this one is the auto here actually design our group produced through the AutoCAD. So this one is the as we can see that this one is the left side is the 2D view of the 2D design of the heat exchanger, and for the right side is the cross-sectional area of a single CO2 tube. So in the CO2 tube, right, inside the CO2 tube there will be 20 inside the shield there will be 20 CO2 tube, and each tube diameter will be 0.009144 meter, and for the number of tubes 20, and also each tube length will be 3.6 meter. And for the shield height, we assume it to be 3 meter. So with after shorten the total length of the tube, which is 72 meter, we make it to be we decide the shield length to be 5 meter, and the number of baffle inserted is 2 meters. Since the baffle length is 2 meter, why the baffle length is so large, as we in our discussion, right? In our group discussion, we decided to make both of the fluid to be in turbulent state. But however, we can't set a very high velocity for both sections. So after setting the after we assume velocity, and then we set the Reynolds number to be 3,500, and the final baffle R410A pipe diameter we get is 2 meter. So we assume that in order to make the R410A reagent fluid gas to be also in turbulent state in the shield, we assume that the baffle length is same as the R410A pipe diameter. And the last part for my explanation is the HEX length. We have inlet 410A temperature graph. So from this graph, we can see that there are two axes. The vertical axis are heat exchanger length, and the horizontal axis are 410A inlet temperature. So based on what the graph has displayed, we can see that the relationship between R410 temperature and HEX length is directly proportional. If we lower the R410 inlet temperature, we will get a lower heat exchanger length required. These data are obtained through the formula our group has made in the Excel. So every calculation is made by Excel, so it should be accurate. So that's all for my part. Thank you.
Thank you for your explanation, Peng. Right now, I will be explaining about costing of our heat exchanger. There are two types of material involved in our heat exchanger, which will be steel pipe, will be used for tube, and 304 stainless steel will be used for shell. So the price per meter of the quarter inch of steel pipe will be 57 ringgit and 55 cents. So the total length we use will be 72 meter. So the total price of steel quarter inch of steel pipe will be 4,143 ringgit and 60 cents. Next, the stainless steel. Price per meter of stainless steel will be 65 ringgit and 78 cents. So the prices are obtained from the website that given below. So the total length will be used for the shell will be 5 meters. So the total price of stainless steel will be 328 ringgit and 90 cents. Together, the total price of our heat exchanger will be 4,472 ringgit and 50 cents. Okay, next I will be explaining about benefit of shell and tube heat exchanger. There are several reasons why we choose shell and tube heat exchanger, because compared to other type of heat exchanger, these have many advantages. First of all, bolting flange. This shell is a cylinder with a bolting flange at each end of the welded pipe. This gives a stronger structure to our heat exchanger. Next, the tubes are fitted with a carefully placed hole in the tube sheets. So baffle also available in our heat exchanger. The first reason for the baffle will be it will help to create the heat transfer turbulence needed. Another reason will be the baffle will be support the tube in order to prevent the vibration caused by the flow of the system. Next, the true counterflow construction is used to prevent pinch point from being limited by heat transfer. So this is a heat exchanger. For shell and tube, it features a double wall construction. It is very important. It is very important to the second tube inside each tube. This will help to the double wall construction provides a substantial protection against leakage and safety for our heat exchanger. Furthermore, our heat exchanger can operate in a system with a higher operating temperature and pressure. So it has no problem to withstand and run in the extreme condition. Last but not least, our heat exchanger has an extremely flexible and steady design, as well as they are no resistant to thermal shock and have no dimension leap. You can design our shell and tube heat exchanger as you needed. Okay, that's for our group. Thank you for watching our video. That's all. Thank you.